Welcome to the Computer Literacy Center's online instructional videos. Today, we will be using Google Sheets to apply various financial formulas such as future and present value. My name is Luke Davis, and I will be guiding you through this tutorial. In this video, we will apply the future value function to determine the amount of money gained on an investment over a period of time. Then, we will identify the current value of investments using the present value function. Finally, we will use the present value function to calculate how much money we can borrow for a mortgage loan. If you would like to follow along with these instructions, please make a copy of the start file that is bundled with this module. Let's start out by using Google Sheets to calculate the future value of an investment based on a constant interest rate. A constant interest rate is not compounded and will not charge interest on previously accrued interest. To begin, let's consider the following scenario. An investment firm is planning on depositing $450 in an investment account over the course of 8 pay periods with a 2% annual interest rate. They want to know what the future value of their investment will be. This example will use the future value function to find the answer. To do this, let's double-click on cell C8 next to future value of investment under scenario 1. Then, we click on the function button, which is our last button on the toolbar, and a drop-down menu appears. Let's hover our cursor over financial and then click FV, which is an abbreviation for future value. This inserts the function into the cell that we selected. It is denoted as equals FV with an opening parenthesis. Then, the function asks us for a few parameters so that a future value output can be calculated. If you don't see this formula helped prompt, click the little blue question mark next to our selected cell. First, let's type in our interest rate. This rate asks us what the interest will be for each pay period. Since we have an annual interest rate of 2% and 8 pay periods, we click on cell C5, then we press the / key on the keyboard, and finally we click cell C6. Sheets will then do the calculation for us of 2% divided by 8. To input the next parameter, we need to type a comma to separate the different pieces of information. As we can see, Google Sheets highlights the next parameter that is expected in the suggestion box. So, the parameter number of periods is the total number of payment periods in the investment. For us, this is 8, so we click on cell C6 again. Next, payment amount is how much money is paid each period. In this case, the financial firm is investing $450 into their account each month. When entering arguments like payment that include cash outflow, such as a deposit into another account, the number will be negative. So, let's click on cell C7 to get that information. We will leave the present value parameter empty. The present value parameter represents the lump sum amount these future payments are worth now. If we leave it empty, then the previous argument payment amount is required. To skip over this parameter, we will type another comma so the function moves on. Finally, we have the optional enter beginning parameter. We can leave this parameter empty or type 0 to indicate that the payments are made at the end of the period, which happens to be the default. If we type 1, then the payments would be made at the beginning of the pay period. Therefore, more interest could accrue on our investment since we would have invested at the beginning of the month versus the end. Now that we have all the parts of the function, we can solve for future value. Let's press the Enter key and the future value of our investment will be calculated. And there we have it! If the financial firm pays $450 per period over the course of 8 pay periods at an annual interest rate of 2%, they will end up with a future value of $3,631.66. Let's quickly evaluate how much money we invested, otherwise known as the principal, and how much money was earned due to our interest rate. To do this, let's double-click in cell C11 next to Principal of Investment. For this equation, we type an equal sign and then a minus sign because we want to see how much we invested as a positive number rather than cash outflow. Then we will click on cell C6 for our total pay periods, which is 8, and then type the asterisk key and click on cell C7 for our payments. Now we press enter and see that our principal invested was $3,600. Now we double click in cell C12 next to amount earned from interest to calculate what our interest rate did for the overall earnings. So, we type an equal sign, then select cell C8, which contains our future value of investment. Then we type the minus sign, and finally we select cell C11. To finish, we press enter and see that the total amount earned from the interest was $31.66. Over time, the financial firm's investment was able to accumulate interest instead of sitting in a normal savings account. Here's another example using the future value function. Let's calculate what an initial investment of $10,000 is going to be worth in 10 years at an annual interest rate of 4%, compounding every month. To perform this next calculation, we double-click on cell F9. Instead of using the formula menu, we're going to simply type equals FV into the cell and press Tab to accept this first suggestion. This is another way of doing the same thing as the formula menu. For rate, we click on cell F5, then we press the / key on our keyboard and select cell F6 to indicate that the compounding happens every month. For number of periods, we click cell F7, then press the asterisk key on the keyboard and select cell F6 because the investment is compounding every month for 10 years. We leave payment amount empty since this is a one lump sum investment. Therefore, we will add another comma to skip over that. Then, in the present value parameter, we select cell F8, which is negative $10,000. If we recall from earlier, it is negative to indicate that we are paying the sum. The end or beginning parameter can be left empty, which will default to 0, meaning the payments will be made at the end of the pay period. Finally, we press the Enter key, which runs the calculation and produces the value $14,908.33. This will be the value of our investment 10 years from now. Alright, now let's talk about calculating the present value. Present value helps us determine how much money we would need to invest today in order to achieve some financial goal in the future. We can think of it as going backwards in time. Instead of seeing how much our money will grow over the years, we want to find out how much money we would need at this moment to end up with a certain amount in the future. Many financial experts use this function for risk assessment to see if they should pursue different financial opportunities. Present value can also be used to evaluate loan amounts that we could borrow and be able to pay back based on our current income. Let's look at our third scenario. Our friend asks us if they can borrow $1,500 right now and promises that they will pay us back $2,000 3 years from now. We will assume that we could alternatively invest the $1,500 at a 5% annual interest rate into a brokerage account. Let's use the present value function to determine which financial option we should pursue. To do this, let's start by double-clicking on cell I8. Then, we type equals PV and press Tab to accept the present value function suggestion. First, let's select cell I5 because it holds our rate of 5%. Second, for number of periods, click on cell I6 because our interest compounds annually over 3 years. Third, we will skip the payment amount parameter by adding another comma. Lastly, we input our future value as $2,000 by clicking on cell I7. Then, we press Enter. Our result will turn out to be negative $1,727.68. The reason this is negative is to indicate that we need to invest that much today in order to have $2,000 3 years from now. Since we'd have to invest about $227 more using the brokerage account to make the same amount of money in 3 years, it's pretty easy to tell that we'd be better off lending the money to our friend who only wants $1,500. Let's conclude with one final scenario for present value. We are looking into buying a home and we want to see what mortgage loan we can afford based on our current income. For this scenario, let's say that we can afford a house payment of $2,500 a month and our bank charges a 6% interest rate annually on our loan over the next 30 years. To find out how much we can afford to borrow, we'll start by double-clicking in cell L9, type equals PV, and then press the Tab key to accept the pulled-up suggestion. Next, we enter in our rate parameter by clicking on cell L5 and divide that by cell L6 because our interest rate is compounded monthly. For number of periods, we click on cell L7 and multiply that by cell L6 because this is a 30-year mortgage that we are paying monthly. Then, for payment amount, we will select cell L8. We need to remember that our payment is negative because we are giving it to the bank. The future value can be set to 0 since there will not be anything left to pay off after 30 years. Finally, we press Enter and the function calculates that we can afford a mortgage loan that is $416,979.04. Therefore, if we find a house that is listed less than or equal to this price, that means we will be able to pay off our mortgage loan in 30 years based on our current income. In this video, we use the future value function to determine the amount of money we would accumulate after investing certain amounts of money over time, as well as a one lump sum. Then, we applied the present value function to evaluate different financial options. Lastly, we found the present value of an investment that will be paid over a period of time. For more information about Google Sheets and other computer literacy topics, please visit our website at weber.edu/CLC.